My name is Jake Ivester, and I am in 5th period Algebra 2.
And I'm Ryan Bohanan, and I'm in 3rd period Algebra 2.
When talking Algebra 2, one of the most important topics and topics that can leave many people confused are higher degree polynomial. So today we'll do some problems step by step going over the key features of higher degree polynomials.
Now, before we get into our problem, we're going to show you a quick tutorial on how to graph on Desmos. So your first step, you're going to search Desmos Graphing Calculator in your search bar and click the first result, which should be desmos.com Graphing Calculator. Now, your third step, once you get into Desmos, is to graph our equation on the left side. And once you've done that, on the right side, you should see your graphed equation. Then write down the graph and its points, and we can complete this equation.
So now, after you've graphed your problem on Desmos, we will start with our x-intercepts, which are given to us here along the x-axis, -7, 0. Second x-intercept is 0, 0. And our third x-intercept is 3, 0. Now, moving on to our second is degree of polynomial. So we add the 2 and the invisible 1 here. And so this is the third degree. So just adding the roots up in any problem will give you your degree. And now for our third, we have end behavior. So as we see here, when x is going to -infinity, we are now trying to find out where f of x is going. And so now, when we see that x is going to -infinity, so -infinity on the x-axis, f of x, or this line is going down on the y, that means that f of x is going to -infinity. Now, when x is going to +infinity, we saw our line is going infinitely down, which means that, again, we go to -infinity. And now, number 4, our local minimum and maximum. Here we see a surge up here, and the maximum of this going to be -4.836, and then our y is 321.294. And now our second maximum is the second surge in our graph, which is right here, and it just so happens that we already have it labeled for us in our x-intercept, 3, 0. Those are our two maximums. Now, on to our minimum. Now, we only have one minimum, and that is right here at the lowest point in this part of the graph, which is 1.086, and our y is -16.085. And 5 is our types of roots. So, it is very similar to our degree of polynomials, where we are using the root. However, now, instead of adding them together, we just say what roots we have. This is a second root, so this is a double root, and here, our invisible 1. And so now we know that we have one single root and one double root.
Now, for how polynomials are used in the real world. Polynomials are used in engineering, computing, and math-based jobs, in management, business, and even in farming.
For example, an engineer designing a roller coaster would use polynomials to model the curves, or a construction worker would use polynomials to design roads, buildings, and other structures.
Polynomials are used very often in numerical analysis, which is the branch of mathematics that deals with the development and use of numerical methods for solving problems.
We chose the topic higher degree polynomials because we know how challenging this topic can be, and having a resource to turn to when you're stuck can be very helpful. This project not only helps the people watching get a better understanding on the topic, but us going through it on our own also helps build our knowledge on higher degree polynomials and how to solve them.
And again, I'm Jake Ivester from 5th period Algebra 2.
And I'm Ryan Bohanan from 3rd period Algebra 2. And thank you for learning about higher degree polynomials with us.